NCM Learning Center. Good morning friends. NCM Learning Center continuously providing the material for GATE, IAS, ISRO, TNEB, RRB, TRB and all other government examinations. Now NCM Learning Center started the classes, YouTube classes for the government examination preparations as per August to September plan. August 15 to August 22 we plan to provide the materials for basic electronics. Then August 22, August 29 we plan to provide the materials for digital electronics. Then 29 to 5 September 5 power electronics material. Then September 5 to September 12 mathematics materials. So as per plan, in this video I am going to discuss about basic electronics course. End of the every week we plan to provide a test. So try to attend our class, try to watch our videos. You can get good marks in the government examinations. In this video we will discuss about BJT current equation, how the electron and holes moves. What is the current equation? BJT current equation we will discuss. This concept is very important for the government examinations. We will discuss one by one. First we should know the BJT structure. We know the diode structure. Diode structure means just P-type and N-type material. Here additionally a N-type material is added. If a structure have N, P, N materials, this BJT is called as Npn BJT. Another one type BJT is there, Pnp, P-type, N-type, P-type. Another one type, Pnp type materials. First we will discuss Npn transistor, then we will discuss about Pnp transistor. The current flow study for the Npn transistor is important to derive the current equations. So you should know the current flow study. So let us like Npn transistors. See N-type materials, P-type materials and N-type material. This terminal is emitter terminal, this base terminal, this is collector terminal. This based on the structure, this base P-type material is very small. Thickness is very small. In the N-type materials, electrons are the majority carriers, holes are the minority carriers. The holes are impurities. In the P-type materials, holes are majority carrier, but electrons are minority carrier. Already the base terminal is very small, thickness is very small, so the majority carrier is very less. So minority carrier will be very less. To make the flow of electrons and holes, we have to apply a forward force from here. We have to give attractive force here. Then only the electron will flow from emitter to collector. So apply the forward bias here, apply a reverse bias here. Then only the electron will flow from here to here, emitter to collector. If you apply the forward force in both direction, the electron does not move. So apply here forward bias. Forward bias means here electron, here negative polarity. The negative polarity repels the electrons, so the electron will move forward. Here we have to apply the reverse bias, positive polarity. The positive charge will attract the electrons, so easily the electrons in the emitter side will move to collector. So the flow of electron and holes moves, circulates. That creates a current. For the Npn transistor, for transistors, to make the flow of electrons and holes, we have to apply the forward bias in this base to emitter region. We have to apply the reverse bias in the collector to base region. Then only the transistor will be in active region. Active region means electron and holes will be movement. When we apply the forward bias in the base to emitter region, electrons will move from here to here, because this forward bias, this negative polarity repels the electrons, so the electron will move here. The base materials have the holes. Holes are the majority area, very minimum amount of holes. So the movement electron here combined with the holes. The electron and holes are combined here, neutralized. The positive and negative charges combined, it will neutralized. So recombined here, all the holes in the P-type material, recombination process takes place. Recombination process means plus and minus combined, it becomes a neutral. There is no charge like us. When the electrons continuously moves from N-type to P-type, the whole now the p-type material will become a negative charge, because all the holes in the base terminal are neutralized, then the electrons are filled in the base terminals. So now the base terminals fully have the negative charge carrier. The negative charge carrier attracted by the VBE and also attracted by the VCB. But the material thickness is very small. Maximum number of electrons moves to collector. That means 95% of electrons in the emitter moves to here. Only remaining part of electrons only recombine and moves to base terminal. This is movement of electron due to the forward bias. At the same time, here reverse bias applied, so due to the reverse bias, the minority carriers holes repelled by the VCB, so the holes moves from collector side to base. In the electrons in the minority carrier, electrons in the base terminal moves to collector side, minority carrier movement. This creates a current. That current is called as reverse saturation current or leakage current IC0. The crossing of alpha times of electrons from emitter to collector and the minority carrier movement creates the collector current. So the collector current is a combination of this current, alpha times of electron current and the reverse saturation current. So the current flow is here. The alpha times of electron only moves after recombination from base to collector. So the current flow is opposite to that of electron flow. So you write this alpha electrons, alpha times of IE. In the base side, electrons movement from top to bottom. So current flow will be bottom to top, base current IB. The total electron crossing emitter to base. So the current will be opposite IE. This is the current flow. Then minority carrier. Due to the minority carrier, the holes in the collector moves to base side, and the electrons in the base side, minority carrier moves to collector. So the current flow will be here. Current flow always same direction that of holes and opposite direction that of electrons. This is the current flow. The combined current of the leakage current and the alpha times of electron movement is called as IC, collector current. Apply Kirchhoff's current law in the junction. Sum of incoming current is equal to sum of outgoing current. Here incoming current IB, alpha E and IC0 all are the incoming current. IE are outgoing current. So we will get IE is equal to IB plus IC0 plus alpha E. This is a current equation with considering the reverse saturation current, leakage current. So IC is equal to alpha E plus IC0. Substitute here, we will get IE is equal to IC plus IB. This is a current equation. The symbol, this is a Npn transistor symbol. Here electron emitted from emitter to collector. Here electron's direction is in direction. So the current direction will be in out. The arrow indicates the holes movement or the current flow. In the base terminal, electrons moves out of the terminal, so the current will flow in of the terminals. So like this. In the collector terminal, electron flow out of the terminal, so the current will flow in of the terminal. So here apply Kirchhoff's current law. Incoming current IC and IB are the incoming current, IE only outgoing current. So IE is equal to IB plus IC. Now we will discuss about the Pnp transistor. Here Pnp transistor means P-type and N-type and P-type materials are combined. Same concept of Npn transistor. Here in this P-type material, holes are the majority carrier and electrons are the minority carrier. In the N-type materials, electrons are the majority carrier. Thickness of the base material is very less. So here majority carrier is very less and also the minority carrier is very less. To make the flow of holes from emitter to collector, we have to apply forward bias here. We have to apply reverse bias here. Then only the holes will flow from emitter to collector. So apply forward bias here. Here positive voltage. The positive polarity will be repelled. So the holes will move away from the emitter. If it is apply the reverse bias, the holes will attracted. Holes in the emitter side does not cross the junction. So it does not create the current flow. To make the current flow, it should be forward bias. EB should be forward bias. Then only the transistor will be in active region. There will be an active movement of holes. When VB is forward bias, the positive polarity repels the holes. So the holes in the emitter side moves to base. Here electrons are present. So the holes pass. So the positive charge and negative charge both are combined here. Recombination process takes place. Recombination process means plus and minus added. It creates neutralized one. Then after recombination process, the holes fill the base side. Now the base becomes positive charge carrier because the holes continuously moves. Now the positive carriers attracted by the both VB and VBC, due to the base is very small, thickness is very small, majority of holes moves to collector. Only a part of holes only moves to base terminal. So all four types of holes from emitter to collector moves. Some very part of holes only moves to base. It causes a current flow, and also due to reverse bias, this negative polarity repels the minority carriers of the minority carriers present. It moves to base. Similarly, in the base already the base will have minority carrier holes. The holes moves to collector due to the reverse bias. Due to the minority carrier movement, there is a reverse saturation current. In the collector side, current flow is due to the both carrier, majority and minority carrier. Both carrier means movement of all four times of emitter electron, and another one is reverse saturation current. In the emitter side, all majority carriers are moved. So this is IE current. Current direction and holes movement direction is same. So IE current moves and recommend here, and all four times of electrons moves to collector. So all four times of IE current moves, and remaining holes moves to base terminal. So IB current flows here. Holes movement and current direction is same. Minority electrons moves to collector to base. Minority holes moves to base to collector. So current flow from base to collector. So in this direction, IC naught. The IC current means the combination of both IC naught and alpha times IE. This is the IC. Apply Kirchhoff's current law at this junction. Sum of incoming current is equal to sum of outgoing current. Here incoming current is IE. Outgoing current is IB plus alpha E plus IC naught. Here combination of IC naught and alpha E is IC1. So IC is equal to alpha E plus IC naught. Substitute here, we will get IE is equal to IC plus IB. When alpha times of holes moves here, this alpha times of holes moves that one. Okay. BJT symbol for the BJT is here. In the emitter side, holes moves in. So current flow moves in. The arrow indicates the holes direction or current flow. Then we will discuss various configuration of transistors. Various BJT configuration means common base configuration, common emitter configuration, common collector configuration. Common base configurations means here there is three terminals. One of the terminal, collector terminal, is used as output. Output is taken at the collector terminal, and input is applied at the emitter terminal. Base is common for both emitter and collector. Then only this configuration is called as common base configuration. In this diagram, this is a common base configuration diagram because this collector is taken at the output side and emitter is input. Input is applied to the emitter and base is common between both input and output. So this is a common base configuration. Current gain is defined in the common base configuration is the output current by input current. So alpha is a common base configuration current gain. The defined parameter is only applicable for the ideal BJT. So if the reverse saturation current is 0, you may define this parameter. So alpha is equal to output current is IC and input current is IE. The alpha parameter is only applicable for the ideal BJT. That means when the reverse saturation current is 0. Second is common emitter configuration. This circuit is example for common emitter configuration because here output is taken at the output collector side, input is applied at the base terminal, emitter is common between both the input and output. So it is a common emitter configuration. The current gain in the common emitter configuration is beta. Beta is equal to output current by input current. Here output current is IC, input current is IB. Then common collector configuration. In the common collector configuration, output collector is common. So output is IE and input is IB. So gamma is equal to output current by input current. Output current is equal to IE, input current is IB. Collector current is common between both input and output. This all the parameters applicable only for the ideal BJT. That means when reverse saturation current is 0. So current gain with considering leakage current. If it is considered, if there is a leakage current, what will be the current gain? We know that IC, so alpha times of IE plus IC naught. This is a reverse saturation current or leakage current. From this equation, alpha is equal to IC minus IC naught by IE. If it is not considered the leakage current, alpha is equal to IC by IE, we considered the formula is different. Now we will find the common emitter current gain formula with considering the leakage current. We know that I is equal to IC plus IB. Substitute here. So IC is equal to alpha into IC plus IB plus IC naught. Simply with this equation. So IC is equal to alpha IC plus alpha IB plus IC naught. IC minus alpha IC is equal to alpha IB plus IC naught. So IC take outside. So IC is equal to 1 minus alpha. So alpha and IB plus IB naught. Divide 1 minus alpha in both sides. So you will get IC is equal to alpha by 1 minus alpha and IB plus 1 by 1 minus alpha and IC naught. We know that if the leakage current is 0, we defined already beta is equal to IC by IB. Here, substitute here IC naught is equal to 0. You will get IC by IB is equal to alpha by 1 minus alpha. So from this equation, we may tell beta is equal to alpha by 1 minus alpha. This is the relation between beta and alpha. Now find the alpha relations. So simply this equation, cross multiply beta minus beta alpha is equal to alpha. Then beta is equal to beta alpha plus alpha. Beta is equal to 1 plus beta into alpha. So alpha is equal to beta by 1 plus beta. This is the alpha relation. You should remember this formula. Substitute alpha and beta values in this equation, will get IC is equal to beta into IB plus 1 by 1 minus alpha. Alpha value is equal to beta 1 plus beta into IC naught. If you simplify this equation, you will get IC is equal to beta IB plus beta plus 1 into IC naught. This is a common emitter current gain equation with considering the leakage current. If it is leakage current is 0, beta is IC by IB. If it is leakage current is not 0, we have to use this formula. So when you are going to write an examination, you should remember this formula. Without remembering this formula, if you derive these formulas during the exam time, it will take long time. It will confuse you. So you cannot answer these questions very quickly. So try to write all this formula in your formula note. Just refer this formula just before the examination. Then only you can get the good marks. So remember the formula. In these questions, if the reverse saturation is not given, we got to use some formulas. If the reverse saturation is given, we got to remember another formula. So first case, the reverse saturation is 0. Common base configuration alpha. IC is equal to alpha times of IE. But reverse saturation is given, we have to use this formula. IC is equal to alpha IE plus IC naught. If the reverse saturation current is not given, so IE is equal to IC plus IB. Same formula is applicable here. Only IC only varies. Then current gain formula, common base configuration current gain, common emitter current gain, common collector configuration current gain. This is only applicable for the ideal BJT only the reverse saturation is not given. If the reverse saturation is given, we cannot use this formula. Only you use this formula. Current common emitter current gain formula IC is equal beta IB plus beta plus 1 into IC, not and this formula. You use this fourth formula. If you use this formula, if the reverse saturation current is given, definitely your answer will be wrong. Fourth one, beta relation, alpha beta relation. Beta is equal to alpha 1 minus alpha. Alpha is equal to beta 1 plus beta. This is the equation. This is applicable for both cases. These are all the formulas you should remember. Next, do it yourself. Here, old IES and GATE examinations questions are listed here. Solve these questions and command your answers. Here, the reverse saturation current is given. You have to apply the reverse saturation formula. In the second question also reverse saturation current is given, so you have to use the reverse saturation formula. If you have any doubt in the discussion, just comment your doubts in our NC Learning Center WhatsApp group. Definitely you can get the answers. Okay. Good. Thank you. Thanks for watching. Click the subscribe button and click the bell icon for notification. Like, comment and share.